Hey friends, did you know that there's a kind of magical energy hidden inside everything all around us? Well, today we're going to explore that mysterious world of chemistry and energy. So let's get started. Okay, so have you ever stopped to think about this? When you're cooking and there's a flame on the stove, where does all that heat actually come from? I mean, when you burn wood or gas, what's the source of all that energy we get? Let's find out. The truth is, pretty much every single object has a kind of sleeping energy inside of it. And that energy is the main topic of our discussion today. We call it chemical energy. So, chemical energy is this hidden power stored inside all matter. It's the stuff that holds atoms and molecules, the tiniest building blocks of everything, together. You can think of it like a super strong glue that keeps everything from falling apart. The real secret to this energy lies within the atoms themselves. See, atoms stick together with these connections, or what we call bonds, and all that energy is hiding right inside those bonds. This connection is called bond energy. A great way to think about it is like a powerful handshake between two friends. The firmer the handshake, the stronger their bond of friendship, right? It's the exact same idea with atoms and their bond energy. And get this, these bonds actually come in two different types. Some bonds, like the ionic bonds inside of table salt, are incredibly strong. The atoms hold on to each other super tightly, which is why salt is always a solid. But other bonds, like the covalent bonds in water or air, are a bit weaker. That's why they can be liquids or gases so easily. Isn't that cool? All right, now we get to the most exciting part. During chemical reactions, these bonds break apart and new ones are formed. And when that happens, some reactions get really hot, while others actually absorb heat and get cold. Let's see how that works. Check this out. When a reaction releases heat and makes everything around it feel warmer, it's called an exothermic reaction. Just think exo for exit. The heat is exiting. And when a reaction absorbs heat, it's called endothermic. Think endo kind of sounds like in. The heat is going in. The best example of a hot or exothermic reaction is burning natural gas on your stove. When methane gas mixes with oxygen, it creates carbon dioxide, water, and tons of heat energy. And that's the heat we use for all our cooking. And look at this. This reaction releases minus 890 kilojoules of energy. Now, that minus sign you see is a secret code. It just means that energy is leaving the system and going out into the surroundings, making everything feel hot. That's what makes it an exothermic reaction. Now let's look at a reaction that absorbs heat. Did you know that lime is made from seashells? A seashell is basically calcium carbonate, and to turn it into lime, you have to heat it up a lot. This reaction just won't happen without heat, because it needs to absorb energy from its surroundings. For this reaction to happen, it needs 176.8 kilojoules of energy. See the plus sign here? That means energy has to be put in from the outside, or absorbed. That's what makes it an endothermic reaction. You might be thinking, how do scientists figure out exactly how much energy a reaction needs or creates? Well, there's some simple math for that. Come on, let's learn how to do the energy calculation. It's actually pretty easy. First, you calculate the total energy needed to break all the old bonds. Then, you calculate the total energy that gets released when all the new bonds are made. Finally, you just subtract the second number from the first, and that gives you the total change in energy. So the main idea is this. If more energy is released when making the new bonds than you spent breaking the old ones, the reaction will get hot. It'll produce heat. That's the real secret behind exothermic reactions. But why are we talking so much about chemical energy? Well, it's because this energy is connected to absolutely everything in our lives. Understanding it is super important for all of us. You see, if we understand chemical energy, we can pick the best fuels for cars, cook our food better, invent brand new materials, and even figure out how the batteries in your toys work. It's also really important for knowing how to protect our environment from pollution. So, from now on, whenever you see something burn or use a battery, you'll remember the science happening behind the scenes. Now, I have a question for you. What other things around you do you think have this amazing chemical energy hidden inside? Give it some thought.